Energy. Good afternoon, everyone. Thank you for joining our Jump into STEM webinar system. I'm Melissa Lapsa from Oak Ridge National Lab, and I'm pleased to have Jeff Munk, also from ORNL, today. The Jump into STEM program is sponsored by the U.S. Department of Energy's Office of Energy Efficiency and Renewable Building Technology Office with support from ORNL Energy Laboratory. Our vision with Jump into STEM is to inspire the next generation of building scientists by focusing on supporting creative ideation and diversity in the field. Jump into STEM program provides for undergraduate and graduate students experience, research, and career possibilities of studying building science. Our intent is to attract students from diverse majors and diverse backgrounds. As we go through this presentation, and then Jeff with his presentation, if you have any questions, please type them into the chat box. And at the end of our presentations, we'll open up the audio for you to ask your questions. But feel free to type them into the chat while we move along. The Jump into STEM program is managed by Mary Hubbard from the U.S. Department of Energy, Dr. Kim Trenbath, and Yahi Simbe from NREL, and myself and Dr. Youngjin Bae from ORNL. The challenges for JUMP are open to any student enrolled in college or university. Our professor team from Georgia Tech, Hampton University, University of Tennessee, Colorado School of Mines, Southern University, Clark Atlanta University, University of Alabama, and North Carolina A&T State University, as well as Tennessee State University, promote the Jump into STEM at their school, and many offer it in their classrooms this fall for a student grade. We also have an advisory panel from ORNL, NREL, the National Science Foundation, and the Oak Ridge Associated Universities that provides guidance to us outreach and the program as a For Jump into STEM, our goals are cultivating diversity of thought by underscoring the importance of interdisciplinary teams. Jump into STEM works with universities for creative building science challenges that can be integrated with coursework curricula. Jump into STEM's network includes leveraging public partnerships with industry partners and STEM organizations for annual student challenges and events. With this slide, you can see a quick snapshot of how the Jump into STEM student competition works. Eligible students can compete for the full paid internships of either ORNL. If you go to jump.ideascale.com, you can see eligibility requirements and the full schedule. Click on how it works at the top of the homepage to view a step-by-step process on eligibility, how to build a team, ideation, and idea submission requirements. Also on the top navigation bar is a schedule for the Jump into STEM 2019-2020 competitions. Eligible students can participate in any of the current online challenges running now through November 15th. These challenges are supported by our online webinar designed to provide insights on industry practices, market issues, and other supporting resources to help students build and generate their idea solutions. After the 3 challenges close on the Jump into STEM team will run a judging process to select finalists to compete on January 31st, 2020 in a final competition event that will either be held at ORNL or at NREL. During this final event competition, judges will award the 2020 Jump into STEM paid internship winners. So our 3 challenges that are running currently, I'll walk through each of them quickly. The first one is on smart sensors and controls for residential building. Participating competitors interested in this challenge topic should develop a unique application that uses sensor data in residential buildings maintaining or improving occupant comfort, and or to provide better responsiveness to the electric grid. Strong ideas will present a approach, identify the sensor data, and how the data will be used. The idea should also discuss the anticipated impact and attack the market plan for the application. The second jump into STEM challenge topic is how to design a healthier air distribution system for a small commercial building setting using your local climate zone. And Jeff Munk will speak a little bit more to. Strong ideas will identify a novel system for the selected climate zone and will present implementation of the solution in a hypothetical building. Solutions should articulate the expected impact from the design system and also include a tech to market plan. The third jump in the STEM challenge topic is focused on pushing the envelope with innovative wall retrofit designs. Students are challenged to design a residential wall retrofit product or system that can address replacement or supplement of current leaky and unhealthy walls. Strong ideas will identify how the wall retrofit will work and will be inclusive of details on how to address the issues of moisture and air tightness. Additionally, the idea solution or more of the following issues: low indoor air quality, high energy costs, and or high retrofit costs. Like the other jump in STEM challenge topics, the idea solution should include some pictures from our final event in April, in conjunction with the Solar Decathlon. Our final event last year enabled our finalists to pitch their ideas in person and network with professors and staff. We had 3 winners last year. 2 were awarded paid summer internships at ORNL, and 1 was awarded an internship at ORNL. And I won't read through all of this. Slides will be available on our later this week, but I did want to share what their experiences were at the different laboratories through their 10-week paid internships. So again, I would encourage all of you to go to our website at jump.ideascale.com and look through the 3 challenges and begin preparing your ideas, as we have 1 month from tomorrow until the 3 challenges close. I'll show you Sarah's, a little bit about her internship program. And finally, Twitter. Again, as we go through the rest of the presentation, if you have questions that you want to ask about the JUMP program or about this technical challenge, you can type it into the chat box and we will address it at the end of Jeff's presentation. So with that, I will introduce Jeff Munk from ORNL. Jeff is a member of the Buildings Integration and Controls Research Group. For the past 10 years at the lab, his research has covered laboratory and field testing of advanced heat pumps for space conditioning and compliance standards, test procedures, and recently the use of building equipment to provide power flexibility to the grid. That I will pull up Jeff's slides.
Okay, thank you, Melissa. So the topic of today's webinar is designing a healthier and energy efficient air distribution system. And this is focusing on small commercial buildings. So taking a look at the energy use of commercial buildings, they account for 18% of the total energy use in the United States. And of that 18%, 44% is used for the HVAC system. So that would include space heating, ventilation, and also cooling. So we've got a lot of energy use in the HVAC system, and Americans also spend a lot of time indoors. So about 90% of people's time is spent inside. So indoor air quality, or IAQ, is a big issue. It has a direct effect on humans' health, and it can also cause issues like sick building syndrome, where there's chemical compounds in the air or mold that cause allergies and illness in the workplace. So because of that, that affects productivity and also costs companies money when that occurs. So typically, indoor air qualities are mitigated through the use of a ventilation system that's combined with the HVAC system. So those ventilation systems would be used to bring in fresh air from the outdoors, bringing them indoors and removing indoor contaminants. So the air distribution system, along with the HVAC system, is designed to provide comfortable temperature and humidity levels inside the building, provide fresh air for ventilation, and then also minimize it. Those are the three kind of main topics for the challenge. So some issues that can crop up with air distribution systems. The first one is duct leakage. So anytime you have either air that's being pulled into a return air duct or supply air out of the duct, you're going to be increasing your energy use and potentially allowing contaminants into the airstream. Along with leakage, there's also duct heat loss or gain. So insulating ducts is a requirement to minimize the heat loss and gain. And then improper duct design can occur when return or supply air vents are not located in optimal locations. And I'll discuss that in a little bit later. So looking at duct leakage, this first slide is going to talk about leakage to an unconditioned space. So over 32% of small commercial buildings are cooled with package units. So a package unit would be an HVAC system that includes the condenser, compressor, evaporator, condenser fan, and evaporator fan, all in a single package. And typically those are located on the roofs of buildings. So the air distribution system has to provide a means of transporting the air from the indoor conditioned space to the HVAC system sitting on top of the roof. So you can see in the top left picture, if the duct system isn't optimally designed, you can end up running ductwork outside of the conditioned space, which is obviously a bad thing in terms of duct leakage and heat loss or gain, because you have those ducts exposed to the outdoor environment, and you don't want to be leaking your conditioned air outside, and you don't want to be losing heat or gaining heat during cooling with those ducts exposed to the outdoor environment. Having the ducts run outside can be minimized by locating the supply and return trunk lines next to each other. So the bottom right-hand picture shows a package unit installed on top of a building here at ORNL. The return and supply lines run straight down through the roof of the building to go to the conditioned space. So there's minimal exposure to the outdoor environment. You can also have leakage to the conditioned space. So this is the same building that had the HVAC unit on the roof. In this building, there are 8 internal zones that are supplied air from the HVAC system, and the ceiling space between the first and second floor and the second floor and the roof serve as the return air plenum. that connects up to the return of the HVAC system. And through some research that was ongoing, we identified that there was pretty significant leakage in the supply ducts into that return plenum area. And so that leakage then reduces the amount of airflow that gets to the occupied spaces in the building, and also reduces the return air temperature to the HVAC system, and thereby reduces the cooling efficiency of the system. So leakage to the conditioned space is also important. It's I guess not as bad as leakage to the unconditioned space, but it's something that should be kept in mind. So looking at proper duct design, things to consider are the placement of the supply and return vents, the velocity of the supply air out of the vents to ensure adequate mixing of the air. That helps ensure air temperature uniformity and the comfort of occupants. So an example of an issue with inadequate mixing, we had a low load home here in Knoxville that we were doing research on. The home was retrofitted with a variable speed heat pump, and the variable speed heat pump could reduce its airflow significantly compared to its full load airflow. And what we saw on the second floor was that on that floor, the supply registers were located on the floor, and there was a low wall return. And when the heat pump ran at low capacity and low airflow, we ended up with the cold air kind of staying at floor level. It didn't mix well in the room, so we had stratified temperatures. And so in addition to the comfort issue there of having a bunch of cold air down by your feet, there's also an energy use implication there, because the heat pump was cooling more than it really needed to be if the temperature, or if the air had been well mixed. So that was the last of the slides on the issues with air distribution system. The following slides go through the challenge. So we're targeting a small commercial building, less than 50,000 square feet. And the challenge points are to provide proper ventilation to all building occupants, maintain occupant comfort, temperature, and humidity, eliminate indoor air quality hazards, reduce energy use compared to the current systems, and meet functional needs of commercial building. I think now we're going to open it up for questions. All right.
Thanks, Jeff. Are there any questions for Jeff on these bullets here expected for this challenge? While we're waiting for type in. Yeah, if you'd rather ask the question verbally, just put that in their chat and we'll open up your line. But maybe Jeff, you can speak a little bit more about some ideas for how students could design a system that eliminates indoor air quality hazards. What would be some things they need to think about there?
Yeah, so I guess one of the main issues there is ensuring that you have the proper amount of ventilation air. And so that would be covered in ASHRAE standard 62.1. That's the American Society of Heating, Refrigeration, and Air Conditioning Engineers. So they have prescribed requirements for the amount of fresh air that needs to be brought into a building based on the size and number of occupants. Another thing to consider is where that fresh air is being pulled from on the building, and also how that fresh air gets conditioned. So typically that fresh air would be pulled into return ducts and pass through the HVAC system before going into the building, which helps ensure that the outdoor air is brought to an appropriate temperature to be supplied to the building.
Okay. A question, what kind of software would you use to model indoor air quality? How can we simulate and test the solutions we potentially develop?
So that's a good question. I guess at the simplest level, there are general rules for air velocities out of supplier registers in order to help ensure proper air mixing. So that's kind of the simplest level. In terms of software, I'm not sure that there's anything in between that and going to like a CFD type model that would let you see how the air is mixed throughout the building.
Okay. Are there any other questions about the challenge requirements? Have questions while you're working on your email them to jump@ornl.gov. There is also some resources listed under the challenge descriptions for reference for students to use while they're doing their research for their solution or ideation. Another minute or two to see if anyone has any additional questions or comments for us. And again, these slides will be available on the website later this week, and they'll be listed under the Air Distribution Challenge. So if you go to jump.ideascale.com and register to gain access to the site, you'll see the 3 challenges. And under each challenge description is a link to the references and also a link to the webinars. And there's 3 webinars per challenge. The envelope challenge will actually have 4 webinars. The last one is tomorrow. So, one more chat question. Does the U.S. government prefer any air HVAC system over others? I think efficiency is the key.
Yeah, I guess I'm not exactly sure what the questions were referring to in terms of type. I think the most common system out there would be a package system that sits on the roof of the building. But yeah, I mean, obviously high efficiency is always good.
Okay, well, thank you everyone for participating in the webinar today, and thanks very much to Jeff for his presentation. And we will conclude the webinar, and we will post this information out on our website later this week. So good luck with your solutions and working on your teams to submit your ideas by November 15th. Thank you.